Now, one or two more concepts I will deal with these identities, namely, if ABC are the angles of a triangle, I start with that again. Of course, it is either you write pi or 180 degrees, then you will have A by 2 plus B by 2 plus C by 2 is equal to, say, pi by 2, or A by 2 plus B by 2 plus C by 2. Rather, I take that to the other side, then I will be having is equal to pi by 2 minus C by 2. Then take tangents on both sides. Tan A by 2 plus B by 2 is equal to tan 90 minus theta, that is cot theta, that is 1 by tan theta, or in other words 1 by tan C by 2. Therefore, you will be having tan A by 2 plus tan B by 2 by 1 minus, say, tan A by 2 into tan B by 2 is equal to 1 by tan C by 2. As usual, I cross multiply and get the result as tan A by 2 into tan B by 2 plus tan B by 2 into tan C by 2 plus tan C by 2 into tan A by 2 is equal to 1. This I will prefer to call it as the third concept which you should remember. If ABC are the angles of a triangle, then this result is true. This is the third concept. If you mark it, that will help you very much. Now, in the same manner, if I multiply the numerator and the denominator by tan A by 2, tan B by 2 and tan C by 2, then I will be having here, say, cot A by 2 plus cot B by 2 plus cot C by 2 will be equal to, say, cot A by 2 into cot B by 2 into, say, cot C by 2. Better you remember this. Why better? You should remember this result so that many of the problems given in properties of triangles are involving this concept. If ABC are the angles of a triangle, then either you can use this result or this result. I will call it as the fourth concept which is involved in the problem also. Now, I will just deal with the problem that was asked there, which will be involving the third concept here. You are asked to find out what is the minimum or the maximum value of tan squared A by 2 plus tan squared B by 2 plus tan squared C by 2. You are asked to find either the minimum or the maximum value, whatever it may be, of this expression. Once this expression is given, I am tempted to think a corresponding expression here. Tan A by 2 is there, tan B by 2 is there. Here also tan B by 2, tan C by 2 is there. Suppose for the sake of simplicity, if I call tan A by 2 is equal to, say, x, tan B by 2 is equal to, say, y, and tan C by 2 is equal to, say, z, then that expression, which I call it as the third concept, will become, say, xy plus yz plus zx equal to, say, 1. For the sake of simplicity, I have marked like that. Now we know that, say, x squared plus y squared plus z squared, say, minus xy minus yz minus zx is nothing but, I used this in the last problem also, say, x minus y the whole squared plus y minus z the whole squared plus z minus x the whole square. This is equal to this result. Now each term here is positive, being a square term. Therefore, this must be greater than or equal to the 0. Therefore, this must be greater than or equal to 0, since each contributory factor in this bracket is a square term that cannot be negative. Maximum it can be 0, for which I have counted here equal to the 0. Therefore, I will be having x squared plus y squared plus z squared minus xy minus yz minus zx, that is equal to say minus 1 is greater than or equal to say 1. Or I will be having tan squared a by 2 plus tan squared b by 2 plus tan squared c by 2 is greater than or equal to 1. Therefore, the minimum value of say tan squared a by 2 plus tan squared b by 2 plus tan squared c by 2 equal to say 1. And this is another important problem which was asked in the competitive examinations. Therefore, you remember all these problems come from the concepts, rather the 4 concepts I have mentioned. Now again you may ask me, sir, how I connect this? You are asked to find the minimum value of this. Suddenly, how do you think about that? A by 2, B by 2, C by 2, that 2 tangents are involved. Therefore, I have got only one concept, that is a third concept like that. From that, you understand how I just got all these results.